So, first thing I wanted to show you was where your pictures are, okay? And I still have to load up your hair is not on there yet, but everything else is on there, okay? I will load it up. So if you guys go to cbstucdavis.edu/gallery, okay? /gallery, what you'll see is probably about 100,000 pictures that we have since the beginning of the center. But you don't want to look through all those, I'm sure. What you do want to do is you want to go to 2009 events, and you say IST 8A, Winter 2009. You click on that. And then what you will see is all kinds of pictures that have been taken in the class. Okay? And you'll see that there's multiple pages here. And as you scroll through the pages, this is when you guys were there. And let's see. I think I didn't load your pictures up there yet. I thought I did. Okay, I guess I still have to do it. The IR photos are there though. I still have to load up I'll make another folder, it'll be called microscope images. I'll put them all on there. But here's the IR photos. And then if you want to see one, you just click on it. And you can see it. These happen to not have any higher resolution than that. That's as big as they get with that camera. Because it's a 320 by 240 camera. But the other images you'll get will be much higher resolution. So I'll put all those on there and you guys can look for them at your leisure. Today, we have one of these that's going to look very familiar to you guys. You're going to be working in groups, and probably you should just work in the groups that you're going to be doing your presentations in anyway. So it'll just be easier. And you'll be filling out this worksheet. You'll look familiar because it's the same thing you did when you had the NASA spectroscope. But today, you're going to be doing it with a $3,000 piece of equipment, which are in front of you. Okay? So, try not to drop them, and also try not to have that open port pointing up, because you can get dirt and dust in there. $3,000. And I'm going to show you some basic things about that software. And then I'm also going to give you guys the manual for the software. But basically what today is about is learning how to use this instrument. So that next week, when you do your experiment that you're going to be doing for your lab report, we don't have to spend a lot of time figuring out how this thing works. Or we can focus on actually using it to collect the data that you need. Okay? So, pretty much today you're characterizing light sources. But instead of getting there's a little bit of red, there's some green, I don't know, I see a little yellow in there, you're going to see exactly how much there is of each of these things. And you're going to learn how to save that data on here, so that then you can call it back, and you can bring it into an Excel spreadsheet, or you can bring it back into this program, or you can do screen snapshots. But you're going to want to have the capability of saving data, because when you go and do your lab report next week, you collect your data for your lab report, you're going to want to actually get data files that you manipulate and utilize in your report. Okay? So, with that said, let me show you a few things. You guys should all be seeing something like this. Anyone not seeing something like this? Oh, you're still loading yours on. Okay, let me do something else first. And one of you is missing the detector because I have it up here. I think it's a group in the back doesn't have one yet. I'll be bringing you this one. This is your fiber optic cable. Okay? The fiber optic cable has a little cover on it on the ends. See the little cover? What you should do right now is take your fiber optic cable and have an open end and immediately go ahead and put it inside here and screw it on. Okay? So now what you've done is you've coupled the fiber optic directly to the USB 4000 spectrophotometer. Now, what does a spectrophotometer do?
It measures the spectrum of light that it receives.
But what does it measure about it?
Intensity.
Intensity. Okay, so it measures, notice, it says here wavelength in nanometers, and here it says intensity counts. Okay? So that's the basic thing it measures. It measures how many photons of a given energy or a given color hit the sensor in a given amount of time. Okay? Does that make sense? Okay. So, virtually all of these have a bad first pixel. So what happens here is, think of this as there's 4,096 pixels that span this region. Okay? And you'll notice that there's something spiked up here. There's a funny color. On my screen it looks red. On here it comes out a little funny because this projector isn't that good. But a lot of you will have that. That's a bad pixel. What that means is that pixel just says, I have a lot of counts. I see a lot of light. When in reality it doesn't. Okay? So the first thing that we do is we use this tool up here, which is a magnifier looking thing that says zoom to a region selected with the mouse. So you click on that and you just grab a little bit to the right of that line and you just go like this. Okay? What that does is it gets rid of that little point. Okay? Another tool that's really useful is this one right here. This tool right here says select graph height to fill window. So it says whatever's in here, make it fill the whole window. Okay? Now I'm seeing the noise. And you notice, for some strange reason, no matter what, even though this thing is in theory closed and there's no light getting to it, it's dark, it's still showing me that it gets between 1,100 and 1,300 counts. Okay? That's known as dark noise. That's the noise of the electronics in the system. Okay? So one of the first things that we learn how to do is to get rid of that. So we come here and we put our mouse over here and it says store dark spectrum. So you cover up everything so that no light's getting into the system. You click that. Still looks the same. And then you come here and you say scope minus dark. So what this does, now it's gone. And I hit this to show me everything again. Now I see that I have plus or minus 100 right around the 0 mark. Did that make any sense? Okay? Now, the important things for you to start off with are this one right here. What that does, you basically don't want to press that, but that zooms out to the maximum in both dimensions. So that would get me back my bad pixel. So I don't want to do that in general, unless I have to start over. This allows me to move what region of the spectrum I'm looking at and scale it. This allows me to scale the X and Y. These are different things. This one allows me to zoom in. Whenever I hit it, it zooms into a region. This one allows me to zoom out. This one allows me to pick the region to zoom in on. And then the important things are over here. Save spectra, print graph, copy spectral data to clipboard. Those are important tools right there. There's also a fourth one called overlay spectra. That's a little bit more advanced. We'll talk about that a little bit later today. Okay? So, any questions about these basic tools up here? The primary ones you're going to use are going to be this one, scale the graph to the height. This one, zoom to a certain region. And you're going to do the store dark spectrum and then subtract dark spectrum. If you want to go back to not subtracting the dark spectrum, you can press that. And all of a sudden you're back to where you were before. You do this, it subtracts it. Now, let me show you a behavior that you don't want to see. Okay? So, I'm going to grab this thing and I'm going to go like this. That looks like a pretty ugly spectrum, right? You can't really see what's going on. There could be a lot of peaks in there. That's when I hit this button and it shows me what it is. See what I just did? Now look at what the number is on the side. You see how it says about 65,000 is where it seems to max out, or 66,000 is where it maxes out? It can go all the way up to 70,000, but it seems to max out somewhere closer to 67, 68,000. This can't detect more than that. That's all it can detect. The moment that you see a peak that's flat on top, it means you've saturated the detector. It can't detect anymore. That'll happen a lot when you're trying to look at the laser, when you're trying to shine a light directly into it. You'll see the thing, like let's say you go, some of you might go outside and look at a spectrum of the sun or off the clouds, and you might see that it goes boom and it flattens out like this and it comes back. It means you've saturated the sensor. And you only know that you've saturated if the values start to be above 66, 67,000, and then you see that flat. If you see the flat, if you see the flat right here, you notice how the flat is empty? It doesn't appear as a straight line going across the top. That tells you haven't saturated the sensor. When you saturate the sensor, you see how it looks flat when it hits the top? That means you've saturated the sensor. Okay? Now, there's something you can do about this. There's three more little spots on this interface that are really, really important. One is called the integration time. You see here how it says 100 milliseconds? That's the amount of time over which it counts the photons. Okay? So, if I'm saturating my sensor here, and I don't want it to saturate, would I count photons for less time or more time? So let's go in here and test this out. I'm going to make this 50 milliseconds. I'm going to make this 10 milliseconds. No, it's not taking. Oh, there we go. It wasn't taking any. Here I'm saturating. Here I've got 10 milliseconds and I'm collecting photons, okay? Notice how small they are? They get to close to what? 6,500? What's the peak that you're seeing there? Under 10,000, right? So if I collect photons 10 times longer, what number do you think I'll have as a peak? If, when I did it at 10 milliseconds, my max was around 6,700, 6,800. If I collect photons 10 times longer, what might I see? Yeah, 10 times the number of counts I had when I did 10 milliseconds. If my light is steady, if I collect light for 10 times longer, I should have 10 times the signal. So if you go outside and you're looking at the sun and you see this thing that's maxed out, you can lower the integration time to get a good reading. Okay? Ideally, yes?
Would you want the integration time that involving enough for it, or to change it with each time?
Very good question. So she's asking, do you change the time with each different light source that you're looking at? Right now, you're trying to determine the spectral characteristics, basically the amount of color and the intensity of the colors relative in a given light source. So for that, you want to get as good and clear of a spectrum as possible. Okay? Now, to do that, you want to get as high a dynamic range as possible. You don't want to see values that go from 0 to 1,000. You'd rather see values that go from 0 to 60,000 if you could. Okay? So you try to maximize the amount of space you're taking. If you were comparing intensities of different sources, then you would always have to keep that steady. You couldn't change that. Then you'd have to figure out what's your brightest source, match your integration time for that brightest source, and measures all the others relative to it. But in this case, you're not doing relative measurements in terms of intensity. You're doing spectral characteristics in terms of what colors are there. So you're just trying to get the best spectra you can with each light source.
Yeah. Also, if it's just that 1,000 or if it's at 60,000, does it have the same kind of pattern?
It'll have the exact same kind of pattern, but here, let's look at this. Here, I'll show you right here. Let's change this to the lowest value, which I think is 5, from what I can remember. Okay, so here we go. I'm going to zoom this out, okay? That's what it looks like. So this is going from 0 to about 4,000, okay? You see the pattern? There's a lot of squiggles in it. Okay? So now I'm going to come in here and I'm going to put this back to, let's say, 50. Now it looks like I have to click there to make it work. Of course, the signal's much higher, so I press this again. See how this looks much cleaner? There isn't all the squiggles everywhere. You see how I can see that there's peaks right here? See these peaks? Let's look for those peaks the other way. Let's go back to 5 milliseconds. So 1/10 is long to go back to 4. Let's go back to 4. And let's zoom in on it. See how it's much harder to tell what's really happening here? Yes?
How accurate are our measurements going to be, like, as far as the intensity? Are we just estimating to like 65,000? Does it tell us exactly, like, for a specific wavelength?
Okay, so you're asking if I wanted to get an exact number. So let's go back to a better, cleaner spectrum here. So if I want to find out a specific value, I just click, and wherever I click, you guys see down here, it tells me a number. That's the value of counts. So if I want to get a specific value, see, I can read specific values.
Okay. Yeah, and you can just type the wavelength and then model it. Okay. I guess for like lasers, since we know what wavelength is, we can really determine.
Well, you're going to try to determine exactly what wavelength it is.
Oh, okay.
Because remember how the lasers sometimes said it's 532 to 536, or it's, I think the blue one said it's 474 to 585 or something. It was kind of ridiculous. You're going to be able to determine that.
Right.
Okay? That's part of what you're doing. So, any question about this changing integration time? Yes.
Well, like, even when it's just at the light, it still kind of goes up and down like that. So how do you know if you've really gotten accurate data, or does that just not matter?
What you're doing today, it doesn't matter exactly what, that you get like a hardcore number fixed. The only way you can get more steady values is by having the whole system be still. You notice that when I'm sitting here, just my little motions can cause a big difference in the reading. So if you're trying to get a very precise reading, you just want things to be very, very still. Okay? So if you were measuring something on a table, like a reflectance measurement, light coming off of something, you'd hold it as still as you can there, and you'd see. But none of it, even for the lab report, it's not going to matter. As long as you're within 10%, it's going to be fine. Because that's not going to be the main point of what you're looking at. Yes, question?
To actually,
Sure.
when we're saving the copies of the spectra, should we save them as a zoomed in version or the zoomed out so that they comparatively have the same graph?
So when you save the spectra, let's go ahead and do one. So I come here and I click save. Okay? And it kind of freezes at that point. So you can let go of things, you don't have to worry. And then I come here and it says desired spectrum processed, file type. This is where I have choices. OOI binary format. That's the native format that it uses. And then I have tab delimited and tab delimited no header. If I pick tab delimited, and then I have to, this is kind of a little kooky the way it works, but you hit browse, and you come in here and you say test, light, give it a name. You say save, and then you got to say save again. It saved it, then you can close it. What I can do here now is go to my desktop. I have a testlight.txt file. If I come and drag it onto Excel, this is what I get. Now I'm in Excel, and I have this long file that has a header that tells me some information about what was going on with the spectrophotometer when I took and saved this reading. And then it shows me the wavelength here and the reading. You see how it says 482.03, the reading is 942. It gives me the reading of each individual point, and then I can graph any region I want in here within Excel. Okay? So I would tend to favor you guys saving, when you save your files, save them this way. Or, the other thing you can do is you can save them in the native format, the OOI native format, and this format. Because the OOI native format, you can then reread into the software. You can open those files again, and you can actually overlay multiple spectra if you want. There's an overlay button on the side. And the overlay only works with their native format. So probably your best bet is save both native and tab delimited. Then you have the most flexibility. And you can do it right from that interface. You just, once you've saved it once, it comes back up with that interface. Don't hit close. Hit browse again, give it another name, change the format, and say save. Does that make sense? Okay. By the way, before I forget, I do want to meet with the group leaders Friday from 10 to 11. All of you said that it was a decent time for you to come. And it probably won't take the whole hour, but if we meet here at around 10:05, we'll discuss details, okay? These are the groups. Okay, let me go back to SpectroSuite. So, the one other point I want to show you on the interface is that you have scans to average. So, another way that you can minimize noise, squiggles, is to average multiple scans. So what happens when you have a very, very weak signal? Like, for example, you guys see that ball over there? You guys see that? Okay. You guys are welcome to stick your finger on it and then put this next to it and see what kind of spectral output comes from there, okay? That's going to be kind of weak. So you're going to probably have to jack up the amount of time, and it might still be noisy. And the way you can deal with that is by averaging some scans. So for example, if I just look at my screen, I'm pointing it just at my screen right now, and just for the sake of showing you how this works, I'm not going to increase the integration time, which would be one way to reduce noise and increase signal. But I'm going to average multiple scans. You guys see what happens? It gets a little bit better defined. Not great, but it's better than that. It's a little bit more stable. So here I go again, I'll show you. And of course it takes longer. You see how the width gets a little bit thinner when we do this? So that's one way you can do it. Take more scans. The other way you can do it is this thing called boxcar width. Boxcar width says, I'm going to average myself with a certain number of points next to me. So if my boxcar width is 5, it says I'm going to look to 5 points to the right of me and 5 points to the left of me and take an average value. And then I'm going to move over one. I'm going to look 5 points to the left of me, 5 points to the right of me, take an average value. I'm going to move over. Okay? So look at what that does. Boxcar width has the same kind of effect, but you lose information because you're averaging, so really sharp peaks will be lost.
So which do you favor? Do you use a combination of the two?
So the very best thing to do right here, since this is still, let me lower the brightness of my screen, and let me go here and say 500 milliseconds. I get a little better signal, but it's still kind of weak. So I would probably, put in a little bit of boxcar width, but not a ton, and I'm already getting a better value. Okay?
And you use averages also? Yeah. I
can also use averages. See, I can get slightly better. The problem with averages is if you make that number really big, it takes a long time to get a spectrum. Because if I say 3, and it each takes 500 milliseconds, that's a half a second, so it takes at least a second and a half to collect the data each time. So it kind of depends on, you might have a precarious situation where I'm trying to take the measurement, and I'm balancing something, and I need the measurement to be taken fast. Okay, and now I just brighten my screen, and you can see I get a much better signal. Basically, the more signal you have, the better it looks. So if that means you have to collect photons for longer, that will make you get a better signal. Okay? I don't expect you guys to understand everything I just told you, but I expect you to at least, that you really can't break anything unless you start tossing this thing on the ground, okay? So don't do that. But the rest, you really can't break anything. Yes? You should try to do as many sources as you can, actually. Now, as you see right here, it's just first, I want you guys to just take 5 minutes and jot down some ideas you have, and then share that with the rest of your group. And then in about 10 minutes, we'll just start going through. And this is where you draw your spectra. You can sketch them out here briefly and also save the files. You might need the saved files for what you're doing on Wednesday. Those might come in really handy. Having good quality files of the lights. Okay? And the other thing I want you to realize is that some things that are on here are not there. Like, for example, I didn't know if I was going to find this. Okay? So therefore, you can just replace one, or fill in another one, however you want to do it. There's front and back of these. Just to make sure you understand what all these are: sunlight, incandescent white. The best we can do for incandescent white right now is a flashlight. Okay? And we have this 2 flashlights, standard flashlights, and we also, on the edge of these black lights, we've got this hidden torch that ends up doing that. Okay? Now, halogen, the only halogen I can find is this projector. You come here to the front, go like that. That's your halogen light. It actually is a halogen light. It's a little projector bulb. Same kind of bulbs that are used in similar to the ones used in here. LED whites, LEDs I got plenty. I've got sets of LEDs. It's no problem. And I would put different colors on there. If you want to try 2 colors, 3 colors, go for it. It's no problem. Laser, red and green, they're out there. Test them both. I also have the blue. The blue's not going to last long, meaning that battery again is breaking. Okay. Light stick. I have 2 light sticks. Though I think I'm going to be a little miserly. I'm going to have you only open one. We need to save the other ones. Somebody gets to crack that. Pass it around. Black light is, I've got 3 different kinds. I've got this one. Never look at these, okay? Black light's not a good deal. I've got this one. These 2. You can put them on 2 fires them up. Okay? Fluorescent lamp white is this. I would suggest the first thing we do is we all do the fluorescent light, and we can turn off the lights. That way we won't have any interference. Okay? Fluorescent paint, it's right here. And remember, you've got the cells, you've also got beads right here. Remember that to get the fluorescent paint to fluoresce, you got to shine black light on it. It's probably good to do, when you're doing black light, also do the fluorescence paint.
Black. It's not going to shine, but
you have to shine the black light on them. For fluorescent, you have to keep the energy source coming. You don't have a choice.
So should we then set the black spectrum with the black light going so that we can count that?
No, the dark spectrum. So you're asking a very rich question, which has to do with actually calibrating things and setting intensities. That's something that we're going to worry about next week. Okay, this week, all you're doing is that dark current, that dark spectrum is purely the noise, the electrical noise, and it always will be that. Next week, we'll move on to those letters A, T, and R, which are absorption, transmittance, and reflectance. Okay, those will require a standard. But the dark spectrum will still be the same way. That's just electrical noise. You always do that as a first step. I'm also going to come around today and I'm going to give you the manual in PDF in case you guys want to look at the manual. Okay? I'll give you that too. Phosphorescent, I think your best bet instead of worrying about phosphorescent paint is do these little guys right here. Okay? A little dark. Just power them up with a little bit of black light and then measure what comes off. Okay? And that's it. You want to add Christmas lights? Those are basically halogens or filters. Incandescents or filters.
For the lasers, are you supposed to actually shine it directly at it or shine it at the table and take a measurement directly at it?
Your best bet is to shine like this is white paper. Okay. Hope that it doesn't fluoresce based on being excited in that car. It probably won't. Okay? Does that make sense? Any questions?
Just a quick thing before we get started. Just follow up on Marco's comment about the presentation team perhaps meeting on Friday. I just want to confirm I'm arranging with the science teacher at the Douglas Middle School in Woodland. And I have from the email that Marco sent you guys earlier that Group A wanted to do middle schools. That would be Amanda, Katie, and Sam. And Group C, first choice of middle school, so that would be Lucy, Rachel, Tim, and Christina. And then Group D is also first choice with most schools. It'll be our June, Jesse, Tom, and Steve. So let's look at it. And so it'll be 3 groups going out to Woodland. You said that I think one of them is early March. So we'll work out the logistics. One of the things to talk about on Friday is a little bit on your schedules. And we'll kind of have to customize this with each team. So find a shorter time that'll be about sort of like going out to the field trip. You kind of need to find a 2-hour block of time for the 3 or 4 of you that matches the class schedule out at middle school. Usually we go out in mid-morning. There's usually a science class around 10 o'clock or 11, and obviously not. Class days is usually a Tuesday or Thursday or Friday, so we can sort that out as well. So those are the 3 groups I'll be in touch with later, over and above the meeting on Friday.
Okay, so why don't you make sure you're in your group, and, well, first by yourself, take 5 minutes and write down what you remember about these different light sources, okay? And then take another 5 minutes and talk with your group about the other piece. See what you might have forgotten with the rest. And then in about 10 minutes, let's start with the spectrophotometer.
Dramatically, that I'm just where exactly because there's a center, it's like way different. And if I do it a little below, then it's a little smaller. And then if I go a little farther away, then it's a little
Are you guys done with the fluorescent? You can just click on it. Just go onto the scribe and click it. The same shape. It's just a different really the only thing you can do is hit save, and then whatever your character kind of is, it kind of fills the screen. So if you hit
How do you go?
The shape is the same. It just keeps going up and down.
Okay, so the shape's more important than...
You're looking at the overall shape. Even if you capture the lower one, and you glue it up, it'll be the same shape. If you get it, it'll just be noisier.
How do you
Quick question?
how do you open the file that you already saved? Overline here. I saved it's a proc spec file. It's called.
Why is not
Oh, that's that one.
What's this one? Can't you remember? I think once you open it,
okay, we want to I'm going to put in a couple of
and then you should say, should have changed the original stuff on the top.
Yeah, we try to save it. Yeah. And it's limited to the
Okay, so
Okay. So this is the purple one.
if you would just draw it and roll it. How do we do that? File, open.
I know, it's kind of weird. It's because you have to browse it for every file.
We saved one of our images. How do we put it? How do we open it? I'm trying to open and it's not letting me. Unless it's overlay.
Oh, yeah, you want to load overlay. Yeah, then just grab, yeah.
But that's not what I want.
Alright, cancel. You want to click on, it's got like a little folder. If you want to open it, click on that button. And then next one over. And find the file.
See, it won't let me open it. I don't know why.
Because you saved it as the text file of the
How did I do it?
tab limit. You saved it as a tab limit file.
And that was not the right one?
Well, if you want to open it, that's the right one to open it in Excel. But if you want to open it in this program, you have to open it as a proc.
So no matter what we do, I have to do it again?
Well, unless you just open it in Excel. You can open it in Excel and grab it. It's probably easier to just open it again.
You mean it's easier to open in Excel?
I mean, it's easier to do it again than to grab it in Excel. So I would try to save it in both formats. Oh, yeah, it's not, it's just a format line. You have to actually include it in this line. Yeah.
Yeah, we're going to turn the lights off, guys. You done with this one? Okay, take it back. Take it back.
Okay, I'm really confused. Sorry.
We're going to turn off the lights.
I don't understand how I'm supposed to be saving this. Let's see if we did it wrong.
Well, no, you did it right. You did the right what you do. Just you can't open the.
How do I freeze it like you did? And then I can just
Okay, can I turn off the lights? Marissa, can I turn off?
You don't need to look at it directly?
Yeah.
We're just drawing the basic shape, right?
Okay, it's just right. Even below. Yellow.
See, guys, when you save them and they don't have the TXT extension, this tab limited, you just have to force Excel to every file. So Excel looks for all files, force it to open, and then it will ask you to say okay, and it'll turn off. The primary one you need is text. That's the one with Excel you can do all kinds of graphing. Did any of you guys use Excel for graphing before? Well, we're going to be, you can use any program you want for graphing, but Excel is going to be the easiest way you can get it. What do you guys find out? You guys look at that? You expect that?
That was the white lady, right?
Yeah.
Which is. Okay, when you do this one, you're going to do this one.
Oh, that's it.
Oh my God. So you have a second pattern there now?
Yeah, this is the white LED. Yeah.
Can you clear that so that we can use that after and use the next LED color?
Yeah, but don't you want to copy this as well?
Awesome.
What's that?
This is the index.
What's that fringe peak around?
Between 400 and 500.
Yeah, it's about 50.
Really?
The highest peak is just over 3,000. Or 30,000.
Find the time to do that.
Are you guys still using the Mac too?
Yeah.
You don't need it if somebody else
I'm going to
needs
show
it.
you something. Okay.
Yeah, I think.
When you guys get back out into the real world and you have access to the internet, there is something in there called the Module Update Center, and you should try to update the software. It'll give you more options.
I don't know. Which kind do we want? Not, we already have it saved as Excel. We want it.
Oh, you did?
Yeah.
And oh, binary.
Once you save it as a binary, can you then export it again as an Excel? From Dora? As a
You have to. It looks like you have to redo it.
Oh, okay.
It doesn't seem to be allowing that.
What do you want the other color to be?
Clear that one's good. We saved it.
Okay. You guys, because you're on a Mac, you have a newer version of software. So.
Click back. Wiggle them out a little bit over the area.
You see exactly what color.
Okay. Let's grab a new one. What are you guys doing next?
Yeah, we're doing LEDs.
All of them? So you guys just did...
We did white and we're doing blue now.
Okay. We're doing blue. Yeah. Let's see, which one should we do?
You guys, I put up your microscope images. They're in the gallery now. They're in a folder.
All the ones that we can't edit that. Because it's more. Yeah, I know. But I think all the ones that we can right here.
No, I'm just saying to like close. So that was the only part.
Here's your hair. That's the hot cocoa.
It's amazing what you can do with this kind of stuff.
That's the fluorescence image, the hot cocoa.
Oh, this is
Did you guys get the Spectrometer thing? Wow,
Yeah.
oh, wow. I'll figure it out while you.
By the way, the hot chocolate fluorescence image is up on the screen in case you're curious what that is.
I put it a little farther away.
Do you have one of the large format printers at the Biotech Center, or would you?
Which is good.
So it's like right.
Let's do let's go with the lasers. Oh, go it's the blue one and the red. Actually, let's do the black light.
We should actually be able to find out exactly.
Yeah, this I haven't seen on
It's under the right thing.
That's pretty good. We have to go back yeah.
Because where the wavelength is going to be exactly. Well, where now.
Do you guys have a black light in here?
No, but we're in line yet.
It's wavelength 473.93.
guys should also move your whole setup and take one on
473.93. That doesn't change.
you go outside, you like the point at the sun of the clouds, so
I don't know. Yeah. So it's 473. Okay, you guys want to see? We did the blue laser. And it's 473.
There should be 3 black lights. Who's got the black light? You have one? He just discovered fluorescence off of white paper.
What are they trying?
Fluorescence off of white paper. This, by the way, is the sugar without fluorescence. I mean, without the fluorescence. This is the fluorescence image of this. Huh? This is sugar. Sugar under polarized light. This is sugar under polarized light too.
There's an odd feature of the Spectrometer. I'm not sure I understand.
There's this line that's drawn through here that goes all the way down to 0. It's like it's a limit.
Yeah, because this detector can only see to that. So you did a zooming that was kind of or you moved the spectrum. So get back to that. This is the bad pixel. Take back to that. Now get rid of the bad pixel by taking your zoom in. No, that way. The box. And select from close to there. Yeah, all the way over. All the way, whatever part you want.
I mean, right now, for this, I just want this.
And then you can click on that. That's from a tongue. That's tongue cells from a rabbit. Yeah. Those are the little sensors for taste. And these are your images. Orange peel. The tea bag. Material on the tea bag. Yeah, that's what the tea bag. This is the wild cinnamon spice or something. The leaves. The feather.
I like the feather. That's my favorite.
This is the other images I took of the feather too. These are fun. This is the downy part of the feather.
This is a microscope, not with the camera, right?
Correct. Well, it's the camera on top of the microscope, yeah. Here's the feather again.
Oh, like so.
And the apple.
So your guys' LED, we have both black lights.
The eraser.
Just saying, they're drawing one. Both sick.
The nickel. The printhead. The razor blade. The graphite lead. Orange.
This is the
hot chocolate.
Looks so creepy.
And then we go to sugars. Okay, remember you got a halogen line here too, okay? You guys can try this one.
And then we have the red and blue lasers. The exact same wavelength.
It's going to be very bright, so I don't know if you're going to be maxing out the sensor right away or not.
Yeah, we did the blue and
Looks like everything into the spectrum.
Yeah, and don't get the flat top. You don't want a flat top.
blue is exactly
You know that something's wrong.
the red is really good to tell.
How's it looking? Things making sense?
Yeah.
We didn't get power to somebody yet, have we? You want
You guys are done with it, right?
yeah.
I like it I would rather have it
but we have to have it. So. I've been saving mine as well.
So can I now reinstall it?
Yeah.
Okay, so we're doing sunlight?
You're going to do something.
Okay, we also need to do fluorescent paint and fluorescent paint. And, I have got an LED blue for you guys.
Oh, okay. Mine is not exactly like you actually have to use it.
Yes, I have them.
You should look at Lucy's papers
I feel like I'm more accurate.
Do you like it?
And then you can't, I just feel like it's more accurate.
Yeah.
So we
Can you hold the equipment while I hold the computer?
You guys can do this one.
We're going to get the halogen light and then yeah.
Do you guys ever graph in Excel?
Huh?
You guys ever graph things in
I've
Excel?
done some graphing in Excel.
It always makes me
Most of the sort of scientific graphing I've done is in WaterPro.
Whatever, you should be able to break it.
Yeah, I don't have WaterPro anymore. It was at school, so. Excel.
What happens? These are going to be a little text. I'll show you that. You guys will
We got the halogen?
We have the sunlight.
Perfect.
Ooh. How did they look? How did the halogen look? How did the sunlight look?
Pull up the halogen. I just closed the door.
This is how
Excellent. Very nice. Very nice. Cloudy sunlight. If there was a nice sunny sunlight, it would be brown.
Yeah. No, it's really fun.
This was your halogen?
No, halogen I haven't copied down yet. I saved it on the computer.
Chocolate chip cookie. It's pretty hard, actually.
I mean, like crystal white.
Yeah. That's the chocolate chip cookie. Yes, I wanted to see that. Let me see it.
Now I'm going to pull up the halogen again. See if the computer stops. I'm pulling up the second one. So that's the halogen.
Yeah.
Did you already do the liquids or
If you're done, then we can clear that and we have the keys.
One page looks really nice. And then?
Oh, this is the house.
Yeah.
So what's this? Oh, this is the paint? Okay, close. So how does this work? We just point it towards one of the paints? Or do I shine the black light on it?
You have to shine the black
Okay,
light.
so then I need somebody to help me. Okay, so which light should we shine it on? All of them or just that? Or it's very small. I need to touch bigger.
By 300.
Oh wow. That big.
So you're getting a lot of ultraviolet in there.
if you're just hard enough.
This is the
Orange.
where are we going, guys? Halogen. Okay. Here it is, guys.
It's fluorescent.
Because we had to choose random colors. As far as I know, this is
Are we turning those in at the end of the day?
No. If you're sitting
So is this
it's really
an exercise? Because for me, the product I don't know if it'll still let me. It would make me It's about 15,000. So.
How are you guys doing? I'd like to take like the last 10 minutes of class to show you a little bit on how you look at these things yourself. Give you a little quick refresher. Yep, we can look for links. And you know how you can tell? Do you guys see? Can you see? Oh, once you the slide again. Okay, so you guys also do something. So you see that's where the light and this thing is, right?
Wait, you mean the other ones aren't UV sensitive?
They are, but not. We have a little bit.
Oh, that's the paper.
That's the paper fluorescence. See, you put higher energy light, it's not.
Yeah.
That's it.
You can have sunlight.
You can. That's the fluorescence. Now let's look at your paper, for example. Get on that. If you look at
Actually, yeah.
we can look at your
My yellow t-shirt.
Unit turbines are pretty much have fluorescence.
Or my coffee cup lid. That's really fluorescent. But the paper, I bet the paper is
Those have to do it. See, it's there. That's a part of a wing of a butterfly. Hot question is going on. You guys do all these things? You did lasers? You guys all do the ball?
Oh no, go ahead, shutting on my computer. Or my
You guys try the
software.
ball? You guys do the plasma ball?
Not yet.
Oh, okay, we can do the hot ball. They're getting it.
Yeah, sure.
Okay, we'll take 2 more minutes, 2 or 3 more minutes. Is everyone getting all their measurements?
The first one was blue, the second was pink.
What is this?
That is the wing of a butterfly. The wing of a butterfly. It's where... No, I had a prepared slide of it already. I didn't torture them. But it's the part where the color changes. This is kind of the structure, and these are the little pieces that make up the wing, and it kind of looks iridescent. That's the tongue. That's like if you were to take tongue cells and cut them like this, a little thin slice like this on your tongue. These are all the taste buds, where things go in and you can taste them. This is fat cells. This is from a plant. You take like a stem and you cut it like this across. These are the vessels where the liquids can go through the plant. And this is sugar. I got lots of sugar. Huh? Did I what? No, it's polarized light. You grow crystals of sugar, and you let the sugar, you make a supersaturated solution of sugar. You put it on the slide, you let it dry out for a couple of weeks, and it makes these fans. These are pollen, fluorescence of pollen grains. That's hot cocoa under polarized light. So the sugar has the color.
Like that or not. Because I did the whole height thing. Try one more time just because yours was strong.
Okay, you guys done taking your readings? Tim, do you have a reading?
Yes.
You guys think of it right?
Very small. Around 400 and 600 now.
Okay, guys, I want to show you just real briefly. I want to ask you a couple of big questions, and I want to show you what he's writing himself. Just really briefly. Okay, so those of you that did this on a PC, you had a slightly older version of the software, because on the Mac it allows you to just update the software and copy it and then spread it out. On the PC you have to have the installer and then update it. So that's part of the reason. So those of you that were on PCs, when you saved your tab delimited files, they weren't saved with the extension .txt. They were saved with the extension, I think, procspec, something like that. Is that what you guys saw? Can anyone confirm this on a PC?
Yeah.
Okay. They're still tab delimited text files. Okay? So what that means is when you go to Excel, you're going to say, open. You're going to look for the file. And when it says all Excel files, it won't show up. You won't see .procspec because it doesn't know what .procspec is. Okay? So you have to basically say all readable documents. And then all of a sudden your procspec file will show up. In this case, I'm on a Mac, so it did put the right extension, .txt. Then you just say open, and you'll get a text import wizard. Okay? Now, because this is tab delimited, you can just hit next, and it already automatically has tab delimited usually. It'll have that chosen. You just say finish, and all of a sudden you have your file. Okay? That's it. Now, you'll notice that in this file, it tells you if there was a dark spectrum present. It tells you how many spectra were averaged, the boxcar smoothing, and the integration time in microseconds. Okay? It just gives you all that information. But now let's say that I wanted to graph this. And now this is a lot of points, right? This is like 3,000 some points. So what I have to do to graph this is I have to select here and go and select all of them. La, da, 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 da. And if you know that there isn't any data at part of the spectrum, you don't have to select all of it, but I'm going to select all of it just to show you. The other way you can do this is you can hold your shift key down, you can go to the bottom, hold the shift key down, and select. Boom, and that selects all of it. And then you have to go into, and this I always forget, somewhere it says graph. Where does it say graph? Insert chart. There we go. Insert chart. Now, depending on which version you have, it may look exactly like this, or it may look slightly different. But what you basically want to do is you want to do a, scatter. Yep, XY scatter. Okay? And your best bet right now is to just do this. And then it's going to take a little while because it's 3,000 points. There it is. Okay, come on. Let me move it. Remember what we took a picture of? This is the only problem. Excel is slow. That's the only problem with this kind of data. Come on. Let me move it. It's not being very. I may have to come up with a way for you guys to reduce the data, so it's not as much. Because this is not behaving very nicely. Do any of you have Excel on your machines? And can try one? Yes. You want to try one? See if it's a little bit better on your PCs?
I tried it before and it worked about as well as what you're doing.
Yeah.
Slightly faster, but
I was trying to make it bigger. Just trying to make it's just being it's being very annoying.
Office 2008 must hate you.
Yeah. Mine works.
Yeah, I think it's the newer version that's not very happy. Plus, I've got a lot of different things running. But anyway, that's the basic idea. You select all of it, the XY points, you select XY scatter, and you pick a chart. Okay? And that's it. And if you have more, the big trick is if you have more, like if you want to graph 3 different ones, then you have one which has your wavelengths and your data values. For the next one, you just copy your data values. For the next one, you just copy your data values. For the next one, you just copy your data values. Then you select everything, and it'll pick the X to be the first column, and the Y's will be the subsequent columns. Okay? If you want to graph more than one thing. But let me know if you have problems with that. Okay? You might want to try just trying to at least graph 2 things on one, so that you can ask me if you have any issues and we can talk about it on Wednesday. So, the other thing I need you guys to bring on Wednesday, okay, I need you to bring some plant parts. What I mean by that is I need leaves. I need you guys to bring leaves. And ideally, you would bring some green leaves and some brown leaves. Okay, if you can find them. If they're from the same tree, that's perfect, but it might be hard to find them. And then bring one other color. So if you find some leaves that are yellow, just bring one other color of leaf. So ideally you'd have a nice green leaf, something in between, could be red, could be yellow, whatever the color is, and a brown leaf. Okay? And then also bring like a petal. A petal. Per group. Okay? You can bring one or more petal, that's up to you. I mean, this is the bare minimum. Bring a petal. And bring a little bit of a stem. Ideally not too thin. Okay? And some other color leaves. Okay? Really cool leaves are the ones that are one type of green on one side, another type of green on the other side. Okay? But you're going to be using leaves and you're going to be using your own skin. You're going to be looking for certain spectral characteristics in these materials. So you guys will be doing transmittance and reflectance. You'll be doing both of those types of measurements, which means that we will use again this instrumentation, but you will get some additional components. Okay? Do any of you have nice, strong flashlights? What? Bike lights, mag lights. You have a mag light? Oh, that one. Yeah, ours. Yeah. If you have like a mag light, it has to be an incandescent, not an LED. Okay? Bring it in. Please bring all your material, your spectrophotometers. Bring right here.